This is going to be a review of Unit 6, in which we studied chemical reactions. And if you notice, I'm on the first page of your workbook. There are a couple of things that we studied in this unit. First, we looked at equations for chemical reactions. The next thing that we looked at was balancing these chemical equations, and then finally looking at different types of reactions. So the first thing that I'm going to review with you is the different types of reactions. The first type that we looked at were called synthesis reactions. And in synthesis reactions, what happens is you have two different either compounds or elements, and they will combine together to create one. So for example, if I have A plus B, they will form together to form AB. Okay. The next type of reaction that we looked at was decomposition. And the important thing for you to know about decomposition is that it is the exact opposite process as synthesis. So instead of A plus B creating AB, in decomposition it is AB, and that produces A plus B. Now remember, for each of these there are very specific types of synthesis reactions and very specific types of decomposition reactions. So I'll show you those and remind you of those in a second. The third type is single replacement reactions. And in a single replacement reaction, what happens is you have a compound that is formed with two different elements, and then you've got one lone element all by itself, and it actually kicks out one of the elements that is in the original compound. So for example, if I have A plus BC, so BC is your compound, what would happen is that A would kick out B, or A would kick out C, and so I'm going to have A kicking out B. So now B is all by itself because it's been kicked out, and you have as a result A and C together. Okay. The last type of reaction that there's actually two more. Double replacement, second to last. And this, what happens in a double replacement reaction, is that there is a complete switching of partners. So in a double replacement reaction, you've got two different compounds. So let's say A and B are together, and C and D are together, and what will happen is that A will form a new compound with D, and C will form a new compound with B. So that was double replacement. The last type of reaction that we looked at is combustion. And in combustion, what happens is you have a hydrocarbon, and that's any compound with hydrogen and carbon, and it reacts with oxygen, and the product of a combustion reaction is always carbon dioxide, CO2, and H2O. Alright, so I'm going to quickly go through each of the reactions. You're obviously going to get quite a bit of practice in class, so I don't expect you to remember all of this right now, but this should be a nice refresher. So I'm going to scroll down. Okay. So this was showing you how to create different types of reactions and writing out the actual reaction, learning about what coefficients are. Remember the numbers in front, subscripts the numbers behind. This was a review of balancing, the law of conservation of matter, which says that matter can neither be created nor destroyed. So in order to create the same number of atoms on each side, you got to put coefficients in front. We'll review that. Okay. Here, this was actually writing out the reactions before you really know what's going to be formed. And one thing to keep in mind for these, one issue that students had was figuring out how to write formulas out. So I'm going to remind you, there are two different types of compounds you can have. You can either have ionic compounds, or you can have covalent compounds. Okay. In covalent, guys, when you have a covalent compound, the number of each atom will be given to you. So for example, if I give you, I don't know, IBr3, I'm just making that up, you would know that the name of that is iodide tribromide, the tri meaning 3. For ionic compounds, this is just as a reminder, I'm going to use iron 2 chloride as an example. You need to create your compound by crossing charges. So if I ever give you a name of an ionic compound, you have to write out the formula by crossing your charges, because ionic compounds have no net charge. So for example, for iron 2 chloride, iron has a 2+ charge, chlorine has a -1 charge, and so the formula for this would be FeCl2. Okay, so I only cross charges when I'm writing the formula out like I did right here. If I'm writing the name, remember, if you don't know the charge of your metal, like iron, because it's a transition metal, then I need to include the charge in the name, like I did right here. If I know the charge of the metal, because it's group 1, group 2, group 3, or silver, or zinc, then you don't need to include the charge. So that's just a little bit of a review of naming, because we're going to be naming as we review this unit and continue further. I'm going to move on. If you're really concerned about naming or writing the formulas, guys, you should pause this video and go back and review your notes. Okay? This is reviewing what I just went through with you and identifying the type of reaction, which we will review in class. That's the same thing with balancing. For synthesis reactions, I'm going to go through these pretty quickly. You've got 3 different types. You've got the typical A plus B gives you AB. You've got a metal oxide, so for example MgO, that reacts with water. And remember that the formula for a base is going to just be your metal crossed with OH. So for example, if I have MgO here, if my metal is magnesium, then the formula for my base would be MgOH subscript 2, MgOH2, because I crossed my charges. For an acid, remember the formula is you balance as you go for those problems. So it's hydrogen with however many hydrogens there are, then your non-metal and however many there are of those, and then oxygen with however many there are of those. All right, and we will continue to review that as we go through. So that was synthesis. Decomposition, there are more decomposition types of reactions, but they're very similar. If you'll look, this is the typical AB breaks apart into AB plus B, A plus B. The second type, you have a metal and CO3, so it'll break up into MO, your metal and oxygen, plus CO2. I'm going to quickly highlight, when you're creating this compound right here, because it's a metal and oxygen, it's an ionic compound, you need to cross charges. Same thing here, when you have your metal and HCO3. To create this, if I were to ask, oh, what is this for you to create this, you need to cross charges. Here you need to cross charges as well. With your base, you would need to cross charges to figure out what this is. For your metal oxide, you would need to cross charges. Same thing for chlorates here, same thing for chloride, okay? But notice, and very possibly same thing here for AB, sorry, and this guy up here. All right, so for all of these, if it's an ionic compound, you gotta cross your charges. Notice for F though, it's kind of funky because it's a non-metal oxide, so that's not an ionic compound. That would be a covalent compound, so that is a balance as you go problem. You do not cross charges for that. All right, I'm going to keep moving on. That was decomposition. For single replacement reactions, guys, remember a metal kicks out another metal, or positive kicks out a positive. So Mg would kick out Ag, a negative kicks out a negative, so Br would kick out I. Do remember, though, that in order for something to kick something else out, it has to be higher on the activity series. So in order for Mg to kick out Ag, Mg has to be higher on the activity series, which as you can see it is, so that reaction would occur. Otherwise, you would have no reaction. Double replacement, you're switching partners. Okay, so Ag would form a compound with Cl, K with NO3. Remember I said innies and outies. So Mg with NO3, H with OH, and we will continue to review that in class. We skipped this section. Finally, for combustion reactions, remember you have your hydrocarbon, so C3H8, for example, it reacts with oxygen, and then it produces carbon dioxide and water always. So I'll write that out quickly. So combustion reactions are the easiest type of reaction because we always know what is going to be produced. The only thing you have to do is balance. Okay? Alrighty. And that is it. Okay, so make sure, guys, to go through this. I have a couple of questions that I'm going to ask you for homework, but otherwise just make sure you go through this, refresh yourself so you're not completely